Alright, so if we look at 5.1, we're going to look at our fundamental trig identities, and there's a lot of them. So we're going to start with our reciprocal identities, which we should all be familiar with from section 4.3. Okay, so we should all know our reciprocals from our last unit. Our quotient identities also come from our last unit, where we know that tangent is sine over cosine, and we know that cotangent is cosine over sine. Alright, our next set of identities are called our Pythagorean identities, which come directly from Pythagorean's theorem. The one you use most frequently is sine squared plus cosine squared equals 1. And you can also sometimes see it written as sine squared equals 1 minus cosine squared, or cosine squared equals 1 minus sine squared. It's just a different form of the same identity. Alright, your next set of identities are called your cofunction identities. And these are probably the hardest ones to remember because you have to remember what turns into what. So your sine turns into cosine, your cosine will turn into sine, and vice versa. So then those are the rest of your cofunction identities. Your secant turns into cosecant, and cosecant turns into secant. Alright, and then lastly, I know I said there were a lot of your even-odd identities. So those are all of your even-odd identities, which tells us that sine of a negative number is the same thing as negative sine. Cosine of a negative number is the same thing as a positive cosine. Tangent turns negative, cosecant turns negative, secant turns positive, and cotangent turns negative. Alright, so I know that's a lot. We're mostly going to use our reciprocal identities and our Pythagorean identities. But it's important that we know that the other ones exist. So for the most part, those are the only ones we use in this class. You'll use the other ones in calc. So if we look at example 1a, we have secant of x equals negative 3 over 2, and tangent is greater than 0, so that tells me the tangent has to be positive. And we want to find our other 6 trig functions. So I know that I'm going to need to find sine, cosine, tangent, cotangent, and cosecant, and secant. But I already have secant, so I only need to find those other 5. So I also know that secant is the same thing as 1 over cosine, which means that all I have to do is flip this fraction upside down, and that's going to give me my cosine. So I know that cosine is negative 2 over 3. That's the first thing I can figure out pretty easily from my secant. For the next part, I'm going to use my trig identity, which is sine squared plus cosine squared equals 1, because I have my cosine squared, but I need to find my sine. So if I know that sine squared plus cosine squared, but we just figured out cosine was negative 2 over 3, so negative 2 over 3 squared equals 1. Well, I know that negative 2 squared is 4, 3 squared is 9. So I end up with sine squared plus 4 over 9 equals 1. So I'm going to subtract 4 over 9. And I end up with sine squared equals 5 over 9. So then if I square root both sides to get the sine by itself, square root of 5 just stays square root of 5. Square root of 9 is 3, so I know that sine squared 5 over 3. Okay, and if I know sine, then I can find cosecant by flipping them upside down. So I know that sine, or cosecant is 3 over square root of 5. So then the last ones that I have to figure out is tangent and cotangent. And I can find tangent by knowing that tangent is sine over cosine. So all I need to do is take my sine and divide it by my cosine. So my sine is square root of 5 over 3. My cosine is negative 2 over square root of 3. So then if I leave the first one alone, change it to multiplication, flip the other one upside down, I get square root of 5 over 3 times 3 over negative 2. The 3's then cross cancel, and I end up with square root of 5 over negative 2 for my tangent. And then I know that cotangent is just tangent flipped over, so I get negative 2 over square root of 5 for my cotangent. Okay, so as I said, all we used on that one were going to be my reciprocal identities and my Pythagorean identities. Let's do another one like that. So if I have sine of x equals 1/2 and cosine of x is greater than 0, then I know that my cosine is positive. And I need to find the rest of my identities. So I need to find cosine, tangent, cosecant, secant, and cotangent. First thing I know is that sine is the inverse of cosecant. So if I do that, then I just have to flip that over. So cosecant is 2 over 1, which is the same thing as 2. Second thing I'm going to do is I'm going to find my cosine using that same Pythagorean identity of sine squared plus cosine squared equals 1. I know that sine is 1/2, so I'm going to get 1/2 squared plus cosine squared equals 1. And I know that 1 squared is 1, 2 squared is 4. So 1/2 squared is 1/4 plus cosine squared equals 1. If I subtract 1/4 from both sides, then I end up with cosine squared equals 3/4. And if I square root to both sides, cosine equals the square root of 3, and the square root of 4 is 2, so square root of 3 over 2. Okay, and then I know that cosine is the inverse of secant, so all I need to do is flip that over, and I have my secant, so 2 over square root of 3. Last one we're going to find is tangent, and tangent is the same thing as sine over cosine. And my sine in this case was 1/2. My cosine in this case was square root of 3 over 2. So if I leave my 1/2 alone, change my division to multiplication, and flip my other fraction upside down, then I end up with 1/2 times square root of 2 over square root of 3. The 2's cancel, and I get 1 over square root of 3. So my tangent is 1 over square root of 3. My cotangent is the inverse of tangent, so square root of 3 over 1, or just square root of 3. Okay, so this is similar to what you guys did in 4.3. The last thing that we're going to do is we're going to simplify trig functions using some of our factoring rules. Okay, so if I'm given sine of x times cosine squared of x minus sine of x, and I want to simplify that, these are kind of like their own separate terms. So this is my first term, and this is my second term. And so the thing that I notice that they have in common is they have a sign in common. So I'm going to factor out a sine of x. If I take a sine of x away from my first term, then I'm left with just cosine squared of x. If I take a sine of x from my second term, I'm left with 1. So I end up with sine of x times cosine squared of x minus 1. Then in my parentheses, I have cosine squared minus 1, which I know is very similar to 1 minus cosine squared, which is one of my Pythagorean identities. 1 minus cosine squared is equal to sine squared. But it's not exactly the same, so in order to flip those terms, I'm going to factor out a negative. So I factor out a negative sine of x. The sine of x stays the same. The only thing I'm changing is I'm taking away a negative. Then these terms flip. So I get 1 minus cosine squared of x. So I know that 1 minus cosine squared is the same thing as sine. So I'm going to replace this with a sine squared of x. So when I replace that with a sine squared of x, I get negative sine of x times sine squared of x. And then I end up with just 3 sines, so negative sine cubed of x. So that simplified becomes negative sine cubed of x. So on that one, all we used was our Pythagorean identities, which you'll use a lot. Okay, let's do it kind of like that. So cosine squared of x times cosecant of x minus cosecant of x. So look at my two terms, my first term and my second term. Things that I notice that they have in common is a cosecant of x. So that's what I'm going to factor out. So if I factor that out of my first term, I'm left with a cosine squared of x. If I factor it out of my second term, I'm left with a 1. We just discovered that factoring out a negative switches these two terms, which is what I want, because I want 1 minus cosine. So I'm going to factor out a negative, so I get negative cosecant of x is now 1 minus cosine squared of x. And what did we say that 1 minus cosine squared of x is equal to? Yep, sine squared. That comes from your trig identity. So I know that that's the same thing as sine squared, so I get negative cosecant of x times sine squared of x. Alright, so any questions? Okay, we're going to work on this today and tomorrow. So you're going to do 377, 11 through 19, and then you're going to skip all the way up to 37 through 50.